Now we're going to talk about standard normal distribution. The standard normal distribution is a normal distribution with the parameters of mu equals 0. So notice that's right here in the middle. Sigma, which is the standard deviation, mu meaning the mean. The standard deviation is 1. This is one standard deviation, two standard deviations. And the total area under the curve is 1. So this goes right along with our probability. And we do use this for probability. So finding probabilities, if you're given a z-score, we can find areas, which is exactly the same as a probability, for different regions under a normal model using technology or table A-2. I'm going to show you a table. I don't recommend you use the tables because I'm going to also show you how to use StatCrunch. Technology is strongly recommended because calculators and software generally give more accurate results than a table. We strongly recommend using technology, which is what we will be doing. We'll be using StatCrunch. Finding probabilities when given a z-score. This is a standard normal distribution table. And if you look at this picture, you can see that it's everything to the left of the z number. And we're looking at the area under the curve. Let's go back here. Table A-2 is designed only for the standard normal distribution, which is a normal distribution with a mean of 0 and a standard deviation of 1. A standard normal distribution has to have a mean of 0 and a standard deviation of 1. There's going to be 2 pages to the table, one for the negative scores and one for positive z-scores. Each value in the body of the table is the cumulative area from the left to the vertical boundary above a specific z-score. And when working with a graph, avoid confusion between z-scores and areas. Z-score is the distance along the horizontal scale of the standard normal distribution, which corresponds to the number of standard deviations above or below the mean. And then the area is the region under the curve, which is our probability. If I have a z-score of negative 2.57, this is the table. What we do is we go down here and we see negative 2.5, and then we go over until we see, goes all the way across here. And if I want 0.07, notice here's 0.07, I would look down this column. This column is the 0.07 column. And so where they intersect is 0.0051. That would be our probability, which is the same as the area under the curve. For example, if I pick positive 2.57, we go down here, there's 2.5, and then we have to find which column is the column with the 0.07. I'll go across. That's my probability that my value is less than or equal to 2.57. If we look at this curve, we would have our z-score further out. It would be this far out even, and it would correspond to all this area to the left of that point. I would have a probability of 0.9949 right here. Are you going to read the table? No, we got everything in StatCrunch. No worries. We have here a bone mineral density test can be helpful in identifying the presence or likelihood of osteoporosis. The result of a bone density test is commonly measured as a z-score. The population of z-scores is normally distributed with a mean of 0 and standard deviation of 1. Perfect. I know now that this is going to work. So these test results meet the requirements of a standard normal distribution. The graph of the bone density test scores is as shown in this figure. A randomly selected adult undergoes a bone density test. Find the probability that this person has a bone density test score less than 1.27. We've already seen how to use the table. Let's see how to use StatCrunch. Stat calculators normal, because we have a normal distribution. My mean is 0 and my standard deviation is 1, which is perfect. And this is where I put my z-score. Probability that this person has a bone density score less than 1.27. And over here, I get my probability. And you can see if I round it to 4 decimal places, it's 89795, which would round up to 8980. Interpretation. The probability that a randomly selected person has a bone density test result below 1.27 is 0.8980, shown in the shaded region. The shaded region, they're talking about this shaded region. Another way to interpret this result is to conclude that 89.8% of people have bone density levels below 1.27. That was all we had to do, is go into StatCrunch, go into calculator, stat, normal, and it gave us everything we needed. Use the same information, but we want to find the probability that a randomly selected person has a result above -1. Stat, calculators, normal. And we can really put in whatever we want. So if we want above -1, that's my z-score. That's not my probability, right? So I put -1 in here, but I want it to be greater than or equal. And I get 0.8413, which is exactly what it shows right here for z equals -1. This is the normal range of bone density readings. So we have less than or equal to -1. Now this is to the left of -1, because here's 0, so this is -1. And we have 0.1587. Example bone density test, finding the area between two values. A bone density reading between -1 and -2.5 indicates the subject has osteopenia, which is some bone loss. Find the probability that a randomly selected subject has a reading between -1 and -2.5. I have stat, calculators, normal, and I want my values to be between. My lower limit is -2.5, and my upper limit is -1. I hit compute. Notice that red line now is not going all the way to the end. It's just going between -2.5 and -1. And the probability of that happening is 0.1524, or 15.24%, which is exactly what this says. Only if you had the table, what you would have to do is find the area to the left of -1. You would start with this value. Then you'd find the area to the left of 2.5, and you would have to subtract this area from this area, because this area is going all the way to the end, but I want to take off this little piece here at the end, which is from z equals -2.5. That gives me my area of 0.1525, which is a little higher than what we actually got. Interpretation. Using the correspondence between probability and area, we conclude there's a probability of 0.1525 that a randomly selected subject has a bone density reading between -1 and -2.5. Another way to look at it is to say that 15.25% of people have osteopenia with bone density readings between -1 and -2.5. Different notations. This is saying we want the probability that our Z number is between A and B. We would write it like this: A is less than Z and Z is less than B. This, of course, is Z is greater than A, and this is Z is less than A.